Good evening, everyone. My name is Neetu Bharti from Civil Fourth Year. Dr. Bhupendra Singh Sir is an assistant professor in the Transportation Engineering Division at IIT Jodhpur, bringing a wealth of knowledge and expertise to our FDP. His impressive background, including faculty positions at NIT Jalandhar and NIT Patna, and his recent research at the University of Nottingham, UK, speaks to his commitment to advancing the field of transportation engineering. Dr. Singh Sir has a strong foundation in pavement material analysis and design, evidence in by his PhD by IIT Roorkee and his master's degree in transportation system engineering from NIT Hamirpur. He's already shared his experience and expertise with us in a previous session, and now he's back to delve deeper into crucial aspect of sustainable road construction. Today, Dr. Singh sir will be focusing on use of cold mix asphalt to increase sustainability in road construction. This is particularly timely topic as we seek innovative solution to enhance the resilience and sustainability of our infrastructure. Let's extend a warm welcome to Dr. Bhupendra Singh sir and get ready to be inspired by his insight on his important topic.
Welcome, Dr. Bhupen. The stage is yours now.
Yeah. Thank you, Dr. Saki. Can I share my presentation?
Yes, sir. Just a minute.
Ji.
Please share, sir.
Yeah. So, is my presentation visible?
Visible, sir.
Okay. Yeah. Okay.
Sir, presentation part is just got disconnected. I think it's not visible.
Okay. Let me share my whole screen then. Is it visible now?
Yes, sir.
And now it is finally in the full screen. It is visible.
Yes, sir. Just click on this hide button, sir.
Yeah. Thank you, Saket. So let me start. Okay. So good evening, everybody, and we have already met when I presented on the first day of this FDP on the use of alternate type of aggregates. So today is the topic that I have chosen is the use of cold mix asphalt. Why cold mix asphalt? Because cold mix asphalt has certain economic and environmental benefits, which makes it good for the sustainability in the road construction. So we'll be covering the different aspects which are related with the cold mix asphalt. And I'll start by presenting the outline of my presentation, which includes introduction. So in introduction part, I'll be giving you a brief introduction about what cold mix asphalt is and what are some of the advantages and disadvantages which are associated with it. Then the second component that we'll be discussing in this presentation is the components of the CMA. So when we talk about the cold mix asphalt, so there are different components which are associated with it. So I'll be discussing those components. Then the third topic that I'll be discussing is the cold mix design. So it is basically the mix design of cold mix asphalt, and cold mix asphalt mix design is a little bit different from the conventional mix design that you do for the bituminous mixtures. So we'll be seeing how it is different, what are the different parameters which are associated with it, and how do we calculate them. Then we'll be coming to the curing of cold mix asphalt. So curing is again very crucial topic when it comes to the cold mix asphalt, and this curing is not same as the curing when we talk about your concrete mixtures, because in concrete mixtures curing means putting samples in the water, but in cold mix asphalt it is just the opposite of it. What does it mean? We'll be discussing them in today's lecture. Then we'll be seeing how can we improve the properties and the performance of the cold mix asphalt so that its field utilization can be improved further. And finally, we will talk about cold recycling, because that is the process which is being used by most of the Western countries to implement cold mix asphalt. So time is limited, so I'll be not going into too much depth of these topics, but I'll be giving you brief. I'll be giving brief about each of these topics. So let's start with the introduction. So when we talk about the asphalt mixture, so asphalt mixture is the mixture of aggregates, filler material, and like a binding material, which is generally asphalt, and some of the admixtures if it is required. So that is the asphalt mixtures. So depending upon the different this classification criteria, asphalt mixtures can be categorized into the different categories like open graded, closed graded, and this and that. But for our today's presentation, the classification criteria that I am choosing is the production temperature, because that makes sense when we talk about the cold mix asphalt. So when we take production temperature as the classification criteria, then asphalt mixtures can be broadly classified into the three categories. First one is the conventional type of asphalt mixtures, which are the hot mix asphalt. Then the second type of mixtures are warm mix asphalt, and third type of asphalt mixtures are the asphalt mixtures which we will be discussing in detail in today's lecture, are the cold mix asphalt. So when we talk about hot mix asphalt, so hot mix asphalt are the conventional mix asphalt that is used for the road construction, and that you guys have seen and you have used, must have used at the different locations. So from the name itself, it gives you some indication. Hot mix asphalt means the temperature must be very high, because we are calling it hot mix asphalt. So the production temperature of hot mix asphalt is generally 160 to 170 degrees Celsius. And when we are using some highly modified binder, let us say polymer modified binder or crumb rubber modified binder, in that case, the production temperature may go up to 190 degrees Celsius also. So that is very high production temperature. Now, what are the advantages of using HMA? So the like biggest advantage of using HMA are its superior performance. So we have seen, if we design like HMA properly, and if we use proper good quality materials, and our construction practices are also good, then we can construct a good quality road with HMA that can last for the time period for which it is designed. So that is the advantages which is associated with HMA. But what is the main problem which is associated with HMA is its high manufacturing temperature. So as we have seen that this its production temperature goes up to 190 degrees Celsius, which is like considerably high than like other type of asphalt mixtures. So because of this high manufacturing temperature, lot of greenhouse gases are emitted into the atmosphere, because for heating up that material, you have to use some kind of fuel. So, and when you are using the fuel and burning it, then you are also producing a high amount of greenhouse gases. So that is why environmental pollution is one of the disadvantages which is associated with it. And then also cost also comes into the picture, because all that fuel doesn't come free. You have to purchase that fuel, and then you have to like burn it. So with the high manufacturing temperature, high production cost, and high environmental pollution are the disadvantages which comes with the hot mix asphalt. So because of these advantages, and because of the global warming is also becoming a global issue nowadays, every country, every industry are trying to make their operation sustainable. So in the similar manner, our road construction industry and road scientists and researchers are also working on the different like methods and different materials, so that, and different practices, so that we can also make road construction sustainable in nature. So one of the method of doing it, one of the ways of doing it is bringing down the production temperature. So working towards that, scientists came up with the like warm mix asphalt. And warm mix asphalt, it has been approximately 20 to 30 years since warm mix asphalt technology is there. But recently, in the past, like 10 to 15 years, it has made a lot of progress, this warm mix asphalt technology. So it means it is not, the temperature, production temperature is not as high as it was in the earlier case. So from the hot we came down to the warm. So that is why the production temperature in case of the WMA, which is the short form for the warm mix asphalt, is in the range of 100 to 140 degrees Celsius. So if you compare with the conventional hot consume, we will be consuming the less amount of fuel and advantages associated with it. And when we compare the performance and durability of warm mix asphalt with the conventional hot mix asphalt also, then many of the studies, including my PhD studies, we have concluded that the performance and durability of warm mix asphalt is on par, and in some cases even better than the conventional hot mix asphalt. So you are not compromising on the performance point of view also, and you are not compromising from the environmental and economic point of view also. So that way warm mix asphalt is a good technology. But what is the problem? It's still produced at a temperature range of 100 to 140 degrees Celsius, for which again you have to heat up the material. And whenever you are heating up the material, you have to anyway consume the fuel, spend the money, and then also increase the pollution. So that is why there was a need that if we can come down, we can move towards the practices where we don't have to heat up the material. So when we talk about the warm mix asphalt itself, then there is another subcategory which has been introduced, and that is called the half warm mix asphalt. And why it is called the half warm mix asphalt? Because in case of the half warm mix asphalt, the production temperature is below 100 degrees Celsius. So it is in the range of 60 to 100 degrees Celsius. So the asphalt mixtures where the manufacturing temperature is from 60 to 100 degrees Celsius, those are called the half warm mix asphalt mixtures. Okay. Now the third type of mixtures which we are going to discuss today are called the cold mix asphalt. So from the hot mix asphalt to the warm mix asphalt, now we have come down to the cold mix asphalt. And from the name itself, you can have this idea that these are the cold in nature, means you don't have to heat anything. So the manufacturing temperature of cold mix asphalt, which is the CMA, is in the range of 10 to 40 degrees Celsius. Now, if you compare it with the hot mix asphalt and warm mix asphalt, it is very low. It means it is the room temperature. You don't have to heat up any material. So whatever the advantages which we get from the cold mix asphalt, they come from the fact that its production temperature is like normal room temperature. Now from this fact, different advantages come out of it. So because CMA does not require any heating, so we are saving a significant amount of energy. And when we are saving a significant amount of energy, that means we are saving the fuel. So fuel cost we are saving at one hand, and then on the other hand, we are also cutting down all the greenhouse gases that would have got emitted if we would have used cold hot mix asphalt or warm mix asphalt. So cost effectiveness and environment friendliness are the two major advantages which comes from the cold mix asphalt. Now, one question may come to our mind when it has so many environmental benefits also and economic benefits also, then why we are not using this cold mix asphalt technology? The reason behind practitioners not being excited about using cold mix asphalt technology are the lower strength of cold mix asphalt. So CMA has lower strength because they have the higher voids, and they also have lower durability. So because of that lower durability and lower strength, the cold mix asphalt technology is not being adopted. So how we can improve on that, which we will be discussing in the today's lecture. So now this is a figure which is taken from a study conducted by the Chapat and Bilal in 2003. So it was like 22 years ago. So here they have summarized and presented the fuel consumption in the production of per ton of different type of asphalt mixtures and how much amount of CO2 emission they cause. Okay, in like equal to zero amount of fuel consumption because you don't have to heat up any material, but for running up your transport vehicles and other that only whatever the fuel consumption is there, it is there, and that is why corresponding CO2 emission is also close to 1 kg per ton, so which is very low. And production temperature also ranges from 0 to 40 degrees Celsius. When we move on the higher side, then comes the half warm mix asphalt, which is called HWMA. So in HWMA, the production temperature ranges from the 60 to 100 degrees Celsius. And here you can see the fuel which is consumed for the production of per ton of HWMA ranges from 1.6, 1.7 kg per ton to around 2.8, 2.9 kg per ton. And the corresponding CO2 emission ranges from 5 to 10 kg per ton. Similarly, when we move to WMA, which is the warm mix asphalt, here the production temperature is increasing as we are moving towards the right. And because here production temperature has reached 110 to 140 degrees Celsius, see the fuel consumption has also considerably increased. So here the fuel consumption is 5 kg per ton to 6.2 kg per tons. And the corresponding CO2 emissions that it is causing is in the range of 18 to 22 kg per tons. And for the conventional hot mix asphalt technology, the production temperature is 150 to 190. And here the fuel consumption is 6.3, 6.4 kg per tons to 7.2 25.4 or 25.5 kg per tons. So if you compare CMA with the HMA, so you can see the difference between the fuel consumption and CO2 emissions. So comparing CMA with the HMA, we can conclude that the CMA is considerably cheaper, solely based upon the fuel consumption point of view, and the environmental friendly also when we compare the CO2 emissions. So this is the summary of their production performance. Now, if we summarize the benefits and drawbacks of CMA, so as we talked earlier, that all the benefits of CMA comes from the fact that its production temperature is room temperature. So that is the major advantage which is associated with CMA, and all the other advantages derive from this sole fact. So first advantage that we get from CMA is that we can do the cold recycling of asphalt. So cold recycling is kind of that we can call is Sone Pe Suhaga. So first we are doing the recycling, which in itself is a very environmental friendly thing. And then upon that we are doing it in a cold way, means we are not heating up any material. We are just using the cold mix asphalt technology, and we are recycling our older roads and creating the new roads. So that is a big benefits which is associated with the cold mix asphalt technology. Second one is the lower energy consumption. As we have discussed, that the energy consumption of cold mix asphalt is considerably, as we have seen in the last slide itself, it is considerably lower than the HMA, which is the conventional hot mix asphalt technology. And because we don't have to heat up any material, so that is the another big advantage is associated with it. Then the third advantage, which comes again from the same fact, because the production temperature is at the room temperature. So that is why the lower greenhouse gas emissions. So greenhouse gas emissions are also negligible as compared to the conventional hot mix asphalt. Then from this fact only, because we are not heating up any material, we are not consuming any fuel, so we are also saving the cost in fuel, in terms of the fuel. So again, economic benefits also derives from the same fact. And finally, the paving benefits are also there. So what does paving benefit means? Paving benefit means there are like couple of advantages which are from the workers and laborers point of view specifically. So we have seen in India, when these workers and laborers works on these infrastructure project, including the road construction project, they don't pay any attention to the safety of these people. So they will not be having any type of safety gloves, they will not be having any type of other safety gears, helmet and mask and those kind of things. And when we are using the conventional hot mix asphalt technology, we are heating up these materials at very like 150 to 160, 170 and 180 degrees Celsius. Then while handling that hot material, if some accident occurs, so then the severity of that accident is very high. Like workers burns because of that, and those burns can be like really serious. And when we compare it with the cold mix asphalt technology, here we are not heating up any material, so we don't have to worry about that, because even if workers use it, like touch it with their bare hand, which they should not, let's say, but if they have to touch it, it will not cause any like burn to them. So that is one paving benefit which is associated with the cold mix asphalt technology. Second benefit is again associated with the workers point of view only. So when you are heating up this material, consuming a lot of fuel and heating up that, so fumes are generated, and most of the time these fumes are inhaled by the workers which are working on the field, and so those fumes are very harmful. So in the long term, they can like create very, very serious breathing problems and illnesses. So from that point of view also, cold mix technology is better, because again here the fumes are not generated. Third thing is that in hot mix asphalt technology, we have to maintain the compaction temperature. So there is a mixing temperature and there is a compaction temperature which is very high. Like compaction temperature is also 100 to 120 degrees Celsius. So you make your material you mix your material in the plants, and then you transport it to the site, and then during that time you have to maintain that temperature, and that is also a challenge. So that kind of problem is not associated with the cold mix asphalt technology, because here you don't have to maintain any temperature, because your mix is already on the room temperature. So your site can be a little bit more far from your plant from that sense, and also weather restrictions are also much lower. So as in case of like hot mix asphalt technology, it is said that you should not pave when the temperature is too low. But that kind of restriction is there in hot mix asphalt, in cold mix asphalt technology also, but it is not as strict as it is in the case of hot mix asphalt. So these are the benefits which are associated with the cold mix asphalt technology. When we see the drawbacks, so we have discussed that the lower strength, when you compare the basic strength, which is the Marshall stability that we check. So now Marshall stability of just unmodified cold mix asphalt technology is considerably lower than your conventional hot mix asphalt technology. Its moisture susceptibility is also high. So again, we know that moisture is the biggest enemy of your bituminous pavements, and if the moisture resistance is even lower than the conventional HMA, then you can judge that the cold mix asphalt's moisture resistance is very poor. Then the third problem is with the rutting. So you guys, I think, must be aware about the rutting. So rutting are the deformations that are formed along the wheel path. Okay, when the vehicle moves on the road, so along the wheel paths, whatever the depressions which are formed, those are called the rutting. So rutting happens at the high temperature when the bitumen becomes soft. So when the load comes over the pavement, then the depressions are formed. So what happens in hot mix asphalt technology, during the production, the bitumen is heated as we have discussed, at 160, 160 degrees Celsius temperature. So because of this heating, short-term aging occurs. So short-term aging, because of that heating, bitumen becomes a little bit hard. So some of its oily components gets evaporated and it becomes hard. And because of that increased hardness, the rutting susceptibility of that asphalt mixture come down. But since in cold mix asphalt, we are not we are not heating up the material, so that advantage we cannot gain from it. So if we compare the rutting performance of our cold mix asphalt, it is poorer than the conventional hot mix asphalt. Then the third is the curing time. So if we construct the road using the conventional technology of hot mix asphalt, we can open the road like after 12 hours or after 24 hours for the traffic. But in case of the cold mix asphalt, it requires some curing time. Okay, so that is also advantage. What is this curing time? We will be discussing more. So this curing time is not similar to that of the concrete, but it is somewhat different. We will be discussing more in detail in the upcoming slides. And finally, see, there are some emission of fumes are also there. So when you are using emulsion as your asphalt binder in cold mix asphalt, fumes are not there. But in some cases, cutbacks are used. So in cutbacks, petroleum products are there, which when are exposed to the atmosphere, those petroleum products evaporates. And because of them, some chemical fumes are generated. So those fumes can be harmful to the workers if you are using bitumen cutback as your binding material. So these are some of the advantages and disadvantages, major advantages and disadvantages which are associated with the cold mix asphalt. Now coming to the components. So as any other type of construction mixture, so our cold mix asphalt mixture also have like three major components. First one is the binding material, second one are the aggregates, and there is third one is also there, which we'll be seeing in some times. So when it comes to the binding materials, there can be two type of binding materials. First one is the emulsion, which is the bitumen emulsion, and second one is the bitumen cutback. So let's discuss the details of the bitumen emulsion first. So what is bitumen emulsion? Bitumen emulsion is a liquid product in which bitumen is suspended into an aqueous medium. This aqueous medium, most of the time it is your water, and it can be other type of materials can also be there, but most of the time it is water. So bitumen particles are suspended in your water medium. Because of that, the viscosity of the bitumen at room temperature decreases, and because of its lower viscosity at lower temperature, we find it useful to be used as a binding material in CMA. Because what does we want in CMA? We don't want to heat up our like binding material. And why do we heat bitumen? We heat the bitumen to decrease its viscosity so that it becomes liquid, and then it can be used to coat all the aggregates together, and then they can be binded, and then the road can be constructed. So if apart from heating, what are the other ways by using which we can reduce the viscosity of our bitumen? That is by making the emulsion of it. So emulsion is the one type of material. Now, when we see the emulsion has two phases. So one phase is called the dispersed phase, like the phase which is, and second one is called the continuous phase. So continuous phase is the large phase in which these small particles of the other phase, which is the dispersed phase, are dispersed. Okay. So depending upon which material is your dispersed material and which material is your continuous material, the emulsion can be classified into the two categories. So first one is the oil in water type of emulsion, which is the most common type. Other one is the first one is the oil in water, which can be this. Second one can be the water in oil, and third one is the miscellaneous. So in oil in water type, what happens? That is the standard one which we use, and in which the bitumen is your dispersed phase. So bitumen particles are dispersed in your water particles. So that is the oil, which is the bitumen in water. So oil in water type. Second thing can be water particles can be dispersed in the bituminous phase. Okay, so this white one can be bituminous phase, and this black one can be like your water phase. So this is called the water in oil. And then the third one is the miscellaneous, in which all the things are going on together. So a typical emulsion that is used for the construction is oil in water type of emulsion. It contains 40 to 75% of the asphalt, 25 to 60% of the water, and then there is an emulsifier also, which helps us to keep these bitumen particles suspended into the this solution, water solution. Okay. Second classification criteria can be the charge. What kind of charge your particles are having. How does these particles remain suspended? Because they have the similar kind of charge. So this charge can be positive charge and charge can be negative charge. So if your charge on your bitumen particle is your positive charge, then that is called the cationic type of emulsion. And if the charge on your bitumen particles or the suspended particles is negative, then it is called the anionic type of emulsion. Okay. Then the third type of classification, which is more important from the construction point of view, is the based upon the setting time. Means in how much time your bitumen is getting, your emulsion is getting setted, and your bitumen is getting released from this emulsion mix. So we will be discussing how that happens. So depending upon that, your emulsion can be classified into the rapid setting, in which the setting happens very quickly. Medium setting takes a little bit more time, and finally the slow setting, in which the setting takes a lot more time. Okay, so now coming to the grades. When we talk about the India, then what are the different grades of bitumen emulsion? So there are 5 type of grades. So broadly 3 categories are there: rapid setting, medium setting, slow setting. And then this rapid setting, 2 type of grades are there: rapid setting 1, rapid setting 2. Then in medium setting, only 1 setting is there. And then in slow setting, again, 2 type of classifications are there: that slow setting 1 and slow setting 2. So that makes total 5 grades of bitumen. Now this is the table that I have taken from the IS 8887 2018, and here you can see this is the table which gives us the requirement, how you can check which grade of emulsion is there and what are the tests you can do to determine that. So physical and chemical requirements for the bitumen emulsion, and this is for the cationic type only, where the charge on the particle is positive in nature. So for that only. So we check the residue on the 600 micron sieve. That is for checking the purity of your emulsion. Okay, is there any foreign particles which is present in it or not? So it should be less than 0.05%. Then the viscosity we check, and based upon the viscosity only, this grade of emulsion is determined. Okay, so viscosity is checked by using the IS 3117 code, and viscosity is checked on 2 temperature. For RS 1, RS 2, and for medium setting, viscosity is checked at 50 degrees Celsius. Okay, because their viscosity is high at 25 degrees Celsius, so their viscosity is checked at 50 degrees Celsius. So these values are given. So you will check the viscosity by using the Sebald-Furel viscometer, and this viscosity in second. And then for the slow setting 1 and slow setting 2, this viscosity is checked at 25 degrees Celsius, because their viscosity is lower as compared to this one. Okay, so there also values are given. So we check the viscosity, and based upon that we decide. After that, all these tests are kind of for the checking the quality of your bitumen. So coagulation is checked at low temperature. That coagulation means whether your all these suspended bitumen particles are getting grouped together or not. So we don't want that. The coagulation should be nil. Storage stability also there is test that also we check in the percentage. So 2%, 1%, those kind of positive charge, because we are talking about the cationic type of emulsion. So charge is positive. Coating ability also checked in, and then stability to mixing with the cement, miscibility with the water. Then we take out the residue also. So in emulsion there is water, then there is bitumen present. So if we take out the bitumen out of emulsion, that is called the residue. So on the residue, we check the evaporation. Okay, after the heating up, how much residue is left, means how much bitumen is present in your emulsion. So that is checked. Then the penetration value of that residue we check. Then the ductility value of that residue we check, and the solubility also, means how much pure that bitumen is. So solubility should come 98%, means 98% of your bitumen should get soluble in trichloroethylene. Then the distillation process we check at the different temperatures, and then the water content also we check on the for this. So these are the tests which are conducted and to check, to grade our bitumen and to check their different properties, okay, for the quality control purpose. Now similar kind of requirements are given for the 3117 IS 3117, which is for the for the anionic type of emulsion. So here you can see the particle size is negative, and all the different type of tests which we have already discussed in the previous slides are there. So I am not going into the detail. So there are two different codes for cationic type of emulsion and anionic type of emulsion. For the cationic type of emulsion, it is 8887, IS 8887, and for anionic type of emulsion, it is IS 3117. Okay, so that can be used to categorize and to check the characteristics of the bitumen emulsion. Now, now coming to the what kind of emulsion should be used where, like, because different type of emulsions are there, how are we going to decide which kind of emulsion we should be using? Then then this rapid setting 1 emulsion is recommended for the tag coat application. So when we do apply the tag coat, we use this rapid setting 1, which you can see in this first figure. Rapid setting 2 can be used for the surface dressing purpose. Here you can see in the second type of thing that surface dressing is being done, and for that surface dressing purposes, rapid setting 2 type of emulsion can be used. So one thing which you will notice that more the emulsion which are having the less viscosity, okay, that is used for the smaller work, and where the viscosity increases, then that is used for more major work. So medium setting, again, now we are talking about for the mix purpose. So medium setting emulsion, they are used for plant or road mixes where the coarse aggregate is 80% or and more. Okay, so there is high chunk of coarse aggregate. Okay, and how do we define the coarse aggregate? All of which retained on 2.36 mm. See, there can be some of the fine aggregates also, but that that should not be less than 180 microns. Okay, practically none of which passes through 180 microns. So more than 80% coarse aggregate should be there, and very less amount of fine aggregate can be there, and very fine filler particles should not be there. Okay, and it is also used for the surface dressing and penetration macadam purpose only. So you can imagine when there are no proper fine aggregates and there are no filler material, then it cannot be used for the proper bituminous mixtures. So that is why medium setting type of emulsions are used for the surface dressing and penetration macadam. Now coming to the slow setting 1 type of emulsion, that can be used for the fog seal, crack sealing, prime coat applications, and slow setting 2 type of emulsion. That is the emulsion that is used for the proper road construction when we talk about it. So it is used for the plant or road mixtures with graded and fine aggregate and substantial quantity of which passes 2.36 mm and a portion of which may pass 75 micron sieve also. So if it is passing 75 micron of sieve, then means it is a filler material. So there can be proper coarse aggregate also, fine aggregate also, and filler material also, means it is a well graded mixture. So when we are constructing the road, that type of mixture we want. Okay, so well graded, for the well graded mixture, this slow setting 2 type of emulsion can be used. Examples are cold mix MSS and SDBC and slurry seal, etc. Okay, now coming to a very important topic which is related with the curing. and which is related with the setting also. So we have seen this rapid setting, medium setting, and slow setting of emulsion, and also curing has also come again and again. So what does that mean? Setting means, see, you are taking the emulsion, and in emulsion bitumen is there and water is there. So what is the material which is responsible for the coating and bonding of the aggregate? That is just the bitumen. So by curing means how that the breakdown of that emulsion happens, how bitumen gets free, and then how that bitumens coat the aggregates, and finally that aggregates bonds together and the mixed is produced. So that whole process is called the curing process, and that water evaporates. Whatever the water which is present in the emulsion, that evaporates. So that is called the curing process. So this curing is not similar as we see in the cement concrete. In cement concrete, curing means the completion of the hydration process, and for that we put our material in the water. But here we want water to break away and evaporate from our mixture. So this is also called curing, but it is a different kind of curing. So how that process occurs? So here the 4 stages are defined. Actually, these are the 3 stages, and the third stage has 2 sub stages. So that is why total 4 stages are there. So initially, when you see any emulsion, so that figure A represents that. So there are asphalt droplets are there, and they contain either positive charge or negative charge. So asphalt droplets carry some charge in it, and because of that similar charge, there is a formation of the electrostatic barrier, so that they cannot come close to each other. So they remain suspended in that solution. So this stage is called the repulsion stage. Okay. When then slowly over a period of time, when emulsion is kept still at a point, then these charges gets depleted over a period of time, and then these two droplets, they achieve the enough energy to overcome whatever the electrostatic barrier now, because it has weakened down now, so it overcomes that, and then they come to each other and form kind of group together. So that is the second stage, which is shown here. So you can see they are still not merged with each other, they are just adhered to each other very closely. So this stage is called the flocculation stage. And then the third stage, which is called the coalescence stage, there are 2 stages in it. So over a period of time when they are together, so you can see there is still water in between them. So over a period of time, the water layer which is between these droplets, that gets thinner and thinner, and these droplets start merging with each other, and that stage is called the coalescence. So in coalescence, those 2 stages are there. In the first stage, the droplets merge together, but some of the water may get trapped in between. Okay, so this is the first stage of coalescence. But over a period of time, because this is also a foreign material, and so this water gets diffused out. So this water also gets out of these droplets, these big droplets, and then these droplets gets combined together, and this coalescence process gets complete. This is the second stage. And when this coalescence happens, then this cannot be reversed. Means you cannot reverse it to make again convert it to the emulsion. Okay, so this is the whole process. Actually, this happens when you during the curing. Okay, and if you keep your bitumen together also for a longer emulsion together like at one place for a longer duration, then also it happens. So settlement, what are the factors which affect these processes? So settlement under gravity, evaporation of the water, shear or freezing will accelerate the flocculation process. Okay, and viscosity also affects the coalescence process. Okay, so this is the breakdown of your emulsion. Okay, now coming to the cutback. Cutback is also another material, another binding material which can be used for our cold mix asphalt. So in emulsion, what we were doing, we were mixing water with the bitumen to bring down its viscosity. Similarly, in cutback, we mix petroleum solvents in our bitumen, okay, to bring down the viscosity at the room temperature, so that we don't have to heat it. Okay, and these solvents can be kerosene, diesel, oil, etc. Okay, so cutback is prepared by mixing bitumen and solvents such as the kerosene, diesel, oil, etc. Now, because these solvents have what does this solvents have property that when they come in the open atmosphere they evaporate. So when we construct the road using this cutback, when in the atmosphere they come, these solvents evaporate. Of aggregates can be used. It may include your crushed rocks, which are the conventional aggregates, then silty sand, slag, gravels, recycled aggregates. All those type of aggregates can be used in cold mix asphalt technology, as we do in case of the hot mix asphalt technology. That before using those aggregates, we check their quality by conducting some of the tests, as we have discussed in that our first lecture, that what are the desirable properties and how do we check those properties. Those tests are conducted for the cold mix asphalt aggregates also. So particle size analysis, because we want to obtain the well-graded mixture. So particle size sieve analysis is done. Then flakiness elongation index, because we don't want too thin or too long particles. Then Los Angeles abrasion values to check the hardness of our aggregates. Aggregate impact value to check the toughness of our aggregates. Soundness test to check the durability of our aggregates, and water absorption. So that that is a indicator of the amount of pores which are present in our aggregates. So these tests are conducted, and if they passes the given values, then those aggregates can be used, whatever values which are given in the MORTH specifications. Now the third type of material which makes our cold mix asphalt considerably different from the conventional hot mix asphalt and warm mix asphalt is water. So you know already when we are using the emulsion, there is some water present in our bitumen. But when we are in our binding material, but when we are making the mix, because the workability of mixture which are being prepared with using emulsion is low. So that is why we have to mix water also, extra water also. There is water already present in the emulsion, but we add some extra water also. Okay. So when emulsion is used for to assist the coating of the aggregate, so that all the aggregates can be coated together. And what is the quality of the water can be used, as the specifications are given for all the construction purposes. So for the cement concrete also, what kind of water we can use? Potable water is advised to use. Similarly, in the cold mix asphalt also, potable water is advised to use. So these are the three major components which are there, and this third component makes, because in hot mix asphalt we don't want any water to be present in hot mix asphalt and warm mix asphalt, but here we are adding the extra water. So that is what makes cold mix asphalt different from our conventional hot mix asphalt. Now coming to the mix design. Okay, so mix design means we are going to decide how much bitumen we have to add to prepare the mixture. Okay, so now because here emulsion is there, emulsion is also very interesting, because there is water, there is bitumen present in it, and then also we are adding the extra water also. So that is why the mix design is very different from the conventional hot mix design. So we use the similar method, which is the Marshall mix design method, but the parameters are different and procedure is also different. So there are new parameters which will be introduced. So first one is the initial residual bitumen content and initial emulsion content. So we want to start the sample preparation, the Marshall sample preparation, but we want some starting point. Okay, how much emulsion we have to take for making the initial samples. So first we calculate what is the bitumen content that is required, because in emulsion there is bitumen and then there is water. So whatever the bitumen content which is there in emulsion, that is called the residual bitumen actually, because when the water evaporates, then bitumen in the form of the residue like remains behind. So that is why it is called the residual bitumen. So first we calculate how much bitumen we will be requiring for the initial sample preparation, and then we will be finding out what is the emulsion, what is the corresponding amount of emulsion we will be requiring. So first thing that we decide is the initial residual bitumen content, and that is calculated by using like this empirical formula, which is given by MS14, which is your Asphalt Institute's manual for cold mix asphalt design. So this says that IRBC is equal to 0.05 times A plus 0.1 times B plus 0.5 times C multiplied by the 0.7. What is A? A is the percentage of the coarse aggregate in your mixture, how much percentage of the coarse aggregate is there. Then B means what is the percentage of the fine aggregate, and C is what is the percentage of the filler material which is there. So as you see, as the size of the aggregates are going down, then the factor, the weightage factor is also increasing. It means you will require more bitumen to coat your smaller aggregate because they have the higher surface area. So in coarse aggregate, this is a 0.05. Then in fine aggregate, it becomes 0.1, and then in filler material it is 0.5. So it is 10 times of the coarse aggregate. So if you take the same weight of coarse aggregate and same weight of like filler material, so the surface area of filler material is approximately 10 times that of the coarse aggregate, okay, and 5 times of your fine aggregate. So that is how we decide, okay, what is the residual bitumen content we want. But that is the residual bitumen. But when we are preparing the mixture, we want the emulsion. Okay, what should be the emulsion content? So that is why we convert it into the emulsion content, and that is called the initial emulsion content. Here also another formula is there, which is IEC is equal to the IRBC that you get from here and divided by the X%. Means X is the bitumen content, whatever the bitumen, 60% bitumen is there in emulsion, or 50% or 70%, how much percentage is there, we put it here, and that is how we get how much emulsion we have to use. Now initial emulsion we have used, but we have already discussed for lubricating the aggregate, for increasing the workability and coating of aggregate, we have to add up the water. So how much water we have to add, that also we have to find out. So that is called the pre-wetting water, because you are wetting your aggregates by adding water beforehand. So that is why it is called the pre-wetting water. So it is the water content at which your mix is neither too sloppy, because too sloppy mixture also we don't want, and too stiff mixtures also we don't want. And this also depends upon the type of mix. If it is a dense graded mix means your more filler material will be there. So that is why your PWC will be high. If it is open graded mix, then it means your fine aggregates and maybe like filler material is not there, then it means it will require the less amount of water. So this pre-wetting water content, or the optimum quantity of that pre-wetting water content, can be like determined by using the two methods. First one is the coating method, and second one is the maximum dry density method. So what we do, we take the aggregate mixture together, whatever according to the gradation, we add the water in it. Okay, let's say we start with the 2% water, 2%, then 2.5%, then 3%, then 3.5%, so on and so forth. And then we mix that aggregate together. So there are two methods. So first one is the coating method, then we add the different amount of water and we mix those aggregates together. And by the visual inspection, we see whether 50% of aggregates have been coated or not. Okay, by the visual observation. So this is a simple method because you have to just add up the like your water, and you just have to check how much coating has been taken place. But again, this is a very subjective thing. There is no quantitative measurement which is there. So I may look some of the aggregates and I may say this is the 40% of the coating. Other person may look at it and he may say it is 30% only, and other third person may look at it and he or she may say it is 70% of the coating. So that uncertainty is there, but it is very easy. Second one is through the maximum dry density. So as we do in the case of soil, that we find out the maximum OMC and MDD by using the Proctor. So here also by using the modified Proctor test, we can find out the water content at which the density of your mix is highest, and that water content can be taken as the optimum pre-wetting water content. Okay, so second one is more suitable, but then again it is more work intensive, because in first one you just doing the coating and checking, second one you have to prepare the sample and then test it and like that. Now the third, because now we have decided okay, what is the initial amount of emulsion we have to add and what is the initial amount of water that we have to add. Now we are going to decide okay, in our total mixture what should be the optimum total liquid content, how much total liquid content should be there. So that is called the determination of the optimum total liquid content at compaction, which is called the OTLC. So your liquid, if you talk about the liquid content in your sample, so liquid content will come from two sources. One is the additional water that you are adding, that is you coming from the maximum dry density test, so that is there. Second one is the water content which is already present in your emulsion. So if you add the pre-wetting water content plus the liquid content of your initial emulsion, if you add them up, so that makes your total liquid content of your mixture. Now we have to find out okay, what is the optimum of it. So what we take the aggregates, we mix it with the emulsion, we add the initial emulsion content which we have calculated here, and then we add the pre-wetting water content which we have found out here by doing the either coating test or maximum dry density test. And then we compact, and then by the 50 Marshall blows on the each side of the sample. So in hot mix asphalt we provide the 75 blows, but in cold mix asphalt we provide only 50 blows on the each side. So by providing the 50 blows on the each side, we prepare the sample. Then in the next sample we increase the water content by 1%. So let's say here in the first sample the total liquid content came like 4.2%. Then in the next one we will make it 5.2%, then 6.2%, then 7.2%, like that. We prepare a number of samples. So now because it requires a curing time also, because that water has to evaporate, emulsion has to break down. So after the compaction, we leave it in the mold itself for 24 hours. Then we take out from the mold and store at 40 degrees Celsius in an oven, okay, for 24 hours. And then after the oven, we again take it out and leave it for 24 hours at the room temperature. So after that, we test it for the Marshall stability, okay. And whatever the Marshall stability we get at the highest liquid content, because you have prepared the sample at the different liquid content, so that content is called the optimum total liquid content, OTLC. Okay, so that is how we get. Now we will come to the main step, which is the deciding the sample preparation of the different residual bitumen content. So now we have the samples are prepared at the different residual content. So residual bitumen content is changed. So in the form of the variation in the emulsion content. So you will add the different type of emulsion. So what we will do, we have decided the OTLC, means optimum total liquid content will remain constant. So, and we will increase the liquid content of the emulsion. So emulsion content we will increase. So let's say initially we started with we will start with the IEC, okay, and then we will increase 1%, 2%, 3% like that, because we have to prepare the sample at different emulsion content. So because OTLC will remain the constant, whatever you have got from here. So we will keep on decreasing the PWC, pre-wetting water content, and that is how we will make. You can make in the in the separation of 0.5%, or you can make it 0.25% also, and you can increase also. But 0.5% is considered to be better thing. It is neither too close nor too far. So at each of these RBC samples, so specimens are prepared. After that, samples are tested for dry stability. Okay, as we have discussed here. So samples are prepared at the different emulsion content. keeping the OTLC same, means increasing the emulsion content and decreasing the pre-wetting content, and then by keeping it in 24 hours in the mold, then storing 24 hours at 40 degrees Celsius in the oven, then keeping 24 hours in the room temperature, and then we test it. So that is called the dry stability. So after finding out the stability, samples are soaked. So we have find out the dry stability, the similar sample, we will soak it. So in case of HMA, how do we do this soaking? We keep our these samples when we do this retained Marshall stability test. Then in HMA we keep it in the like hot water bath, 60 degrees Celsius for 30 to 40 minutes. But since cold mix asphalt's initial strength is very low, if we keep it at 60 degrees Celsius in water, it will not be able to bear it. The sample will break. So that is why we have to change our conditioning criteria, water conditioning criteria. Here for CMA, soaking is done by keeping the sample in the soaked water up the half of the depth. So half of the water in half of the sample is soaked in the water at the room temperature, okay, for 24 hours. Then the sample is reversed, and the other half of the air void range in cold mixes. It is 3 to 5% actually in Morth. Here you can see air void is 3 to 5%, which is not possible. 3 to 5% can never come in cold mix asphalt currently. Okay, so more achievable range is 8 to 4%, 8 to 14% that you will see. So void is very high, like 14%, up to 40% it can be. So that is why strength is lower. So for design purpose, we can take 7 to 10%. So in our laboratory studies also, we also keep it between 7 to 10%. And that is how we decide okay, what is our optimum residual bitumen content. So that was the mix design. So this is the flow chart which summarizes everything. And I'll share this presentation with you guys. You guys just go through it because I think we are running a little bit short on time. So let me cover the other topics. Now coming to the curing. So curing is the time which is required by the cold mix asphalt to achieve its full strength. Okay, so this curing is different from the curing of the cement concrete. During the curing process, we have already discussed what happens. Water which is present in the cold mix, it evaporates. And when it evaporates, it leaves the bitumen behind. Okay, and then that bitumen coats up the aggregates and then bonds the aggregates together, and this mix achieves its final strength. So again, one question may come to our mind that what can be this duration of the bitumen? So bitumen duration depends upon the many factors, which we'll be covering in the next slide. But it has been reported that in some cases it may happen very fast, like it may happen in 2 to 3 days also. And in some cases it has been reported it has taken like up to 2 years for the curing to be completed. Okay, so curing process is highly dependent upon the in situ conditions. So you can imagine if the hot and dry kind of conditions are there as they are in Jodhpur, so it will happen very fast. Curing will accelerate. It will accelerate the curing, and curing will happen maybe in 3 days or 5 days or 7 days. But if wet and cold conditions are there, means if you, let's say, Guwahati or some place where a lot of rains happens and cold weather also happens, then the curing slows down and it will take a longer period of time. Okay, so curing is a function of the dissipation and extraction of water. So drying and wetting cycles are also affect the curing durations. So what are the factors which affect the curing? Mineral composition of the aggregates. Means if the aggregates have the minerals which are more water absorptive in nature, then it will take longer period of time for water to go out. Type of emulsion also. Type of emulsion means how much water it is having. Amount of water which is present in the mix after compaction, because during the compaction, some of the water will go out, expelled out of the mixture, but what is the water remaining after the compaction, that water will determine how much time it is going, the mix is going to take for the curing. Type of mix, well graded, open graded, and gap graded. If there are more voids in mix, means water will evaporate quickly. If it is a dense mix, then water will take more time to evaporate. Type and amount of compaction, as we have discussed here, during the compaction water gets expelled out. So if the compaction amount is higher, more water will be expelled and curing may accelerate, but we have to be very careful because lubrication is not there, proper lubrication is not there in cold mix asphalt. So if you apply too much of the compactive effort, then your aggregate may break. Okay, so you have to be careful. Traffic loading and volume means if let's say road is open for the traffic and traffic volume is more and traffic loading is more, then also water may expel out and the curing may accelerate. And EC2 climatic conditions, which we have already discussed. Now we have discussed that curing this cold mix asphalt has very low strength and all those kind of, let me quickly cover the remaining topic. So it has low strength and all. So how can we increase the strength so that we can use it in the field more? So one thing which we have, which many of the studies have reported, and we have also observed in our study, if you use cement as a filler material, 1 to 2% of the cement if you use, then you will find that the strength development in cold mix asphalt is faster. Like very early strength develops because hydration of the cement take place, and that improves the overall strength and bonding of the aggregates with each other. Moisture susceptibility also increases. Strength parameters, all the other strength parameters means indirect tensile strength, on those kind of strength also increases. Curing rate also improves because some of the water which is present in our mix gets utilized by cement for the hydration process. And then this hydration process is an exothermic process, means it evaporates, heat gets released during that. And due to that heat, this evaporation accelerates. And also it has been seen that the reflective cracking also decreases when we are using the cement. But one of the disadvantages associated with the cement is that cement is a very costly, first one, it is costly material. Second one, it is also very carbon heavy material, means its carbon footprint is considerably higher. So that is why some of the studies have reported, okay, if we add even 2% of the cement, then the carbon footprint of our cold mix asphalt becomes equal to the hot mix asphalt. So then there is what is the purpose of doing all these kind of things when your carbon footprint gets equal to the hot mix asphalt? So therefore we should be careful how much cement we are using in our cold mix asphalt. Second second material which can be used is the fly ash. So fly ash, as we know, it has cementitious property and it is a waste material also. So 2 to 6% you can use. It also improves the strength and volumetric properties. It also improves the moisture resistance. Although the improvement is not as much as we observe in case of the cement, but improvement is there. We have also seen in our study. Okay, so fly ash can be used. Then lime is another material. So if you use again to around 2% of the lime, again it improves the strength, it improves moisture susceptibility considerably, and it also improves the rutting performance. But then again, it has the same problem as the problem associated with the cement. It may not be as resource hungry and expensive as cement is, but it also is carbon intensive material. So we should be careful before using the lime also. Then there are some chemical additives also which different people have used. So we can use those additives. Then there are fibers also people have used to increase the strength. So there are natural fibers also, there are artificial fibers also, and there are some miscellaneous type of materials also people have used, and they have reported it to be improving the overall strength of our cold. These include serpentine oil and those kind of materials. So there are a number of materials which are available which can be used to improve the overall strength of our cold mix asphalt. And then this strength, in some cases, it comes in the laboratory conditions, because our studies have been in the laboratory conditions. We have seen it reaches up to the level of hot mix asphalt. Okay, so more field studies should be taken, so that more conclusive evidence can come out of it especially for the field application purpose. And that will give the confidence to the contractors and practitioners, and they will be using it more in the field. Okay. Now, one of the methods of cold, like applying the cold mix asphalt technology is cold recycling. Again, because we are like running short of the time, I will not go into the detail. I'll just give a brief about it. So cold mix recycling. So as I talked earlier also, so this is like a sone pe suhaga, because we are doing the recycling and then we are doing it in the cold way, okay, without heating up the material. So it is cost effective also and environmental friendly also. So it is a rehabilitation method. So if the old payments are there, so we take those old payments and then in the cold mix asphalt technology way, we mix it again and we lay it. Okay. So it also uses reflective cracking also can be controlled. So what are the advantages which are associated with the cold recycling of the asphalt? Whatever the distresses are, those get eliminated, strength gets improved, riding quality gets improved, efficiency wrap means this recycled material can be used in the high quantity, and low cost of engineering and minimum environmental impacts are there. So all the benefits are there. Now how do we do it? I will quickly go through it. So what we take, let's say there is a road and we want to recycle it and again construct a new road. So we take some samples out of that road. From that bituminous samples, we check how much bitumen which is present in that sample. And then we do the gradation also to check what is the gradation of our aggregates. Okay. So then we check the nature of the aggregates and nature of the binder also. So for the, because we are doing the cold recycling, then we use the medium or slow setting emulsion, what emulsion we will be adding. So there are some empirical formulas which is based upon the experience, those are used, and using this formula we try to find out, okay, what is the amount of the virgin binder which is required, what is the amount of total binder which is required, and out of that we subtract the binder which is already present in the material. So that is how we get the amount of the virgin binder which will be required. Similarly, we have the gradation of the aggregates which is present in our this wrap material. So then based upon that, we find out what is the virgin amount of aggregates, what is the additional aggregates we have to add. So that we find out, and if we see our bitumen, whatever which is present in our wrap, due to the aging has become very hard and brittle. What happens? Bitumen over a period becomes very hard and brittle. So if we feel that, then we add some of the rejuvenators and then we mix all this together and then lay it together. Like here you can see they are taking out this mixture, then they are mixing this additional bitumen, rejuvenator and aggregate here in this machine, and then they are again laying it down. See here, behind them you can see laid new road which is there. So depending upon, it can be cold in place recycling, means you can do everything here only, or it can be central plant recycling also, means you can take out the material to the plant, there you do the mixing and then again you can take it back and then you do the construction. So in the first one, which is in place, you save the transportation cost also. So it is more environmental friendly, more cost effective. But in cold plant recycling, because the mixing is happening at the plant, so quality control is more there. Okay. So that's all for today's presentation, and I hope you guys enjoyed it, and thank you for being with me for like 1.5 hours. Thank you so much.
Thank you, sir. It was a very nice and thorough presentation. Uh, we really thank you for this comprehensive overview of the cold mix asphalt, and you have certainly highlighted its potential to revolutionize the sustainable road construction, sir. From understanding the component and the design principle to exploring the intricacy of the curing and the improving CMA mixtures, Dr. Singh has provided us with a wealth of knowledge. And sir, the insight into this cold recycling further emphasize the eco-friendly nature of this technology, sir. It's clear that the cold mix asphalt offers a compelling alternative to traditional method, especially in the context of increasing sustainability and resilience in our road infrastructure. So I thank you, sir. Again, we have few questions over here in the chat box. The first question is, what's the lowest temperature of CMA laying in the cold zone? This one is from the Mr. Pramod.
See, usually we don't recommend it to go below like 10 degrees Celsius. We don't recommend it from my personal experience point of view, because that way coagulation happens fast, and again then the quality will not be good.
Okay.
So below 10 degrees Celsius, like from my experience point of view, we don't recommend it.
Another question is, if the CMA soaked in water, it loses its strength, as you have told in the PPT. Can you tell how to fill the water-logged port holes, negative water pressure zone, using CMA?
Again, like whenever you are filling up any potholes where there is water, doesn't matter whether you are using the CMA or hot mix technology. First you have to clear it out of the water. You have to take out the water. You cannot leave it water already, like water which is there. You have to clean it up. You have to take out the water. You have to properly clean it up, and then you have to apply the prime coat and tack coat, and then only you can use either CMA or hot mix asphalt technology also if you want to use. So water you cannot leave in your potholes before applying the correction course on it.
So another question is, what is performance grade bitumen? I think this is not from the PPT, but performance grade bitumen. So
yeah, I'll give a brief, because again performance grade bitumen is a detailed topic in itself. So performance grade bitumen means, we see currently in India, how do we decide the grade of the bitumen? Earlier we used to decide based upon the penetration
grades.
So we used to drop a needle, and based upon how much penetration that needle is making in our samples, we were deciding what should be the grade of the bitumen, but that is not nowhere scientific in nature. Then we move towards the viscosity grading. Okay, so in viscosity grading, what do? We find out the viscosity of the bitumen at 60 degrees Celsius, and based upon that, we decide what is the grade of our bitumen is. But if you see, bitumen is a very interesting material which changes its form and its property depending upon the temperature very quickly. So if you see, the average temperature of the pavement is approximately 25 to 30 degrees Celsius. Then the maximum highest temperature that is considered for the pavement is 60 degrees Celsius. And during the construction, we heat up the material up to 150 degrees Celsius also, bitumen. So see, these are the very different temperatures which bitumen has to undergo during the lifetime. And if you are checking the property of the bitumen at one temperature, then three different type of bitumen can give you the same property, but their high temperature performance and low temperature performance properties and performance can be totally different from each other. So in order to deal with this issue, in USA, super pave technology, super pave concept came into the picture, where the study went on for the years, 4 years, and with the amount of $150 million in 1980s, actually 87 it started. And then they came up with these specifications which are based upon the performance of our bitumen in the field. So they constructed some road stretches, then they studied the performance, then they find out what are the important factors which are affecting that performance, and based upon that they came up with the grading criteria, and that grading criteria is called performance grading, in which we fix the bitumen parameters, and then we check over which temperature range those parameters are met, like what is the minimum temperature over which we are getting those values, and what is the highest temperature at which we are getting those parameter values, and that range we give as our performance grading. Like your usual performance grading is PG minus 20 to 70, means your minimum pavement temperature can be minus 22, where this bitumen can be used, and 7-day maximum average pavement temperature can be 70 degrees Celsius, where this pavement can be used. So that is a brief overview, and there are a lot more detail. Hopefully in the future, if we get a chance, I may give you a lecture on the performance grading of bitumen also.
Sir, you mean it has been already 35 years the research has been done on this performance grade and the Indian government has not adopted it yet.
Yeah,
So,
actually, performance grading is only used in bitumen, and in UK they are even not using viscosity grading. They are still using this penetration grading
penetration grade.
itself. So it's not like just Indian government is behind, but like all over the world they are behind. Now I think Professor Swami from IIT Delhi, he is doing a project to come up with the performance grading criteria for Indian conditions also. So he is doing that project, and hopefully very soon in the next couple of years we will get this performance grading criteria for India also.
There is one more question. Can we use other industrial waste ashes like rice husk ash as a filler?
Yeah, definitely we can use. Wherever you will find that there are some cementitious properties present in any type of waste. So we have also used not the rice husk ash, but we have used GGBFS, ground granulated blast furnace slag, because that also has some kind of binding properties. So we have used in the lab and we have found that also improves the performance. So wherever you can find some of the cementitious properties present in the ashes or any type of material, that can be used as a filler material in your uh, cold mix asphalt.
So one more question in the chat. It's from Tejas Patalkar sir. In the presence slash intervention of bitumen, do OPC and or PFA fly ash produce and maintain the network of CSH gel in the CMA mixture?
So that kind of research I have not come across. So again, that is a topic that can be that can be explored in our current study also. Whatever the study that we have conducted, that is like very primary level studies where we have just added the cement and we have checked all the different properties on the like physical and mechanical level, but we have not gone into the depth of chemical level and like microscopic level to know okay, what is the internal behavior is there, how this CSH gel network is performing inside the mixture or not. So again, this is again an excellent area of research where the research can be done, and that's the answer that I have presently.
So one last question is here. Could you provide a comparative analysis? I think that would be big. Comparison basically of the initial cost and long-term maintenance expenses associated with cold mix asphalt versus conventional hot mix asphalt.
Again, currently I don't have the numbers. The only number that I had, I have presented that in that figure. If I come across any, and I have not see when you talk about the cold mix asphalt, so again because it is not used for the like the main road and those kind of things, so a broad level, a comprehensive level studies has not taken place. So I have also not seen any documents where they have come across with this like how much initial cost is lower and how much overall LCA level cost is lower,
Cost
life cycle
analysis.
cost assessment is lower. But from our own laboratory perform level, whatever the studies that we have conducted, after adding 2% of the cement and 2% of the lime, also in one of our papers you can also find it, we found out okay, that the cost was like 13 to 15% lower than the conventional HMA. Okay, but over a long period of time during the life cycle cost analysis we have also not done, and I have also not seen in many of the studies. So as I said, cold mix asphalt is currently being utilized for the minor road construction, but studies have not taken place. So that, yeah, that is again an area of research where you can concentrate on.
Sir, that's the end of the question answer session, sir. All the questions have been asked. Very thorough and detailed answers that have been given by you, sir. Thank you again, Dr.
Thank
Singh,
you, sir.
sir, for the sharing your expertise and inspiring us to explore innovative solutions for a greener future. Thank you, sir. Thank you for
Thank
joining
you.
us.
Thank you, Saket, and thank you all the participants.
Thank you,
See
sir.
you.